All right, geometry fans, welcome back. This is section 7.2. In this lesson, we will define similar polygons, interpret similarity statements, calculate a scale factor for similar polygons, and use properties of similar polygons to solve problems. We're going to get into a lot here, and it's really important you understand the basics. So let's start here. Read along with me. Don't just gloss over this. Make sure this makes sense to you. Some definitions and some symbols here. Figures that have the exact same size and exact same shape are called congruent figures. You see that little symbol there, equal sign with that little tilde, that squiggle over the top? That means congruent. So make sure we're good with that symbol. We talked about triangle congruency previously. Okay, we're going to use some of the same ideas, but similarities can be a little bit different. So we're going to be studying now figures that have the same shape, but not necessarily the same size. And this is what similar figures are. Okay, these two things right here, 1 and 2, these are two properties of similar figures. Okay, the first one is that corresponding sides are proportional, so they're not the same, but it means as one gets bigger, the other one's going to get bigger at a proportional amount. Okay, then the other thing is that the angles are congruent, so that's the big difference now here. We have congruent angles. Okay, so proportional side lengths, congruent angles. Now, if you look over here at this table on the side here, we have symbols that go along with our words. So similar, we're going to use this little squiggle or this tilde. Congruence, we're going to use the equal sign with that same tilde, that squiggle over the top. Equal, we know approximately is like 2 squiggles. All right, so when we write these statements, just like congruency, it's very important that we note the order they go in. So look at example 1. So we have A, B, C, D. We don't know what it is. It's some quadrilateral with A, B, and C, D, similar to E, F, G, and H. We want to list all the pairs of congruent angles and write a proportion that relates corresponding sides. Okay, so it might help you to draw a little figure here. So if we start out, let's say this is some kind of quadrilateral or rectangle. Here's A, B, C, D. Now, when I draw this similar to this figure E, F, G, H, I'm going to go in the same order, so my corresponding parts line up. So if A is in that top left-hand corner, I'm going to put E in this top left-hand corner. Then next is B, so I'm going to put F in the top right-hand corner, so it corresponds to B. Now notice as I went around, C now is in that bottom right, so that means G is going to go. That corresponds to C, and H goes in that bottom left. Now, it's important, the way I drew this now shows me which ones correspond, which tells me which angles are congruent and also which sides are proportional. So, if we look now at our figure, it's very easy to tell which angles are congruent. So we have angle A, that was the first one, is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G, and angle D is congruent to angle H. Alright, so there's all the corresponding angles. Now we can put any of the corresponding sides together. So if we just want to make one proportion, what's key is that we write our corresponding sides in a ratio. So let's say I want to start with side AB. I want the corresponding side with AB, which is EF. The way I drew it, they're in the same position. Okay, the way they are in the similarity statement, they're in the same place. And that's equal to, now I can pick any other sides. Now, since I started with A, B, C, D, on the top of my ratio, I got to start with that on the second ratio. So now this is going to be, let's go to AD. And the side that corresponds to AD in my other quadrilateral is EH. There's a proportion, and that's how we're going to set it up. Notice how consistent we were setting those up with our corresponding parts. All right. Oh, we have a definition here. The ratio of corresponding sides of similar figures is called A. When we actually take this numerical ratio, we call this a scale factor. Because when we talk about things being proportional, it means we multiply them by something to get the other length or the other side. All right, so now let's take a look at example 2, and we want to determine if these polygons are similar. Okay, the way we're going to do this now is to look at, first, do we have congruent angles? So look at our markings on this triangle. We have angles that are congruent, right? And it looks like we have 3 angles that are congruent. Now, when we test our sides, we got to be really careful to make sure we're lining up the corresponding parts, okay? So here's what I'm going to do. I'm going to label these corresponding angles the same way. So let's say I start here. Now this one just has that one line, or that one arc, so that's going to go with this guy here. Let's call that D. Okay, let's call this B. B's going to correspond with E over here, and C is going to correspond with F. Okay, so see how those line up. Now I just have that so I can column those. Now if we look at that, we're going to check now, are our corresponding sides proportional? So when I make the ratios, they should all have the same ratio or the same scale factor. All right, so let's start with AB. And we can see here that AB is going to correspond to DE because it matches those angles. So I have 6 over 10 all right, and now I'm going to take my other next corresponding side, and let's say BC, and we can see that that corresponds to FE. So BC is 12, and that corresponds to FE, which is 20. All right, now if I simplify each of these, I get 6/10, or 6 over 10 is 0.6. The easy way to do this is put it in your calculator, and you can see the decimals are the same. Now, those are the same, so we're good. Now we just need to check the last one. So we checked AB and DE. We checked BC and FE. Now we need to check AC, which is 15, and FD. And if we divide that again, we see that that's going to give us the same thing, which is 0.6. So there we go. These are similar figures because they have the same thing. Now, the ratio of our sides, if we think about this, and this is where it's easy to see, I'm going to simplify this. Instead of a decimal, each of these simplify to 3/5. Okay? So 3/5 might be our scale factor, but when we use the scale factor, we need to consider, is our shape getting bigger or smaller? So if I start with ABC, see this little arrow we have here, we're saying, okay, let's take ABC and go to FDE. Okay, ABC is getting bigger when it goes to FDE. So we want to consider, that's one possibility of my scale factor. The other one is that it could be the reciprocal of this, which is 5/3. And in this case, it is because it's going from smaller to bigger. So when you consider a scale factor, we want to consider is it getting smaller or bigger, and if it's smaller, we use the value that's less than 1. If it's getting bigger, we're going to use the value that's greater than 1. All right, I'm going to let you guys go ahead and do B. This is the same exact idea. Now notice we only have 2 sides to check here because we know with quadrilaterals, with these right angles, that these are going to be rectangles. So we're just going to check those couple sides. Make sure you show your work. Go ahead and pause it here. All right, and we're back. So you should have calculated that, yes, these are similar figures. And our scale factor is 1/2 when we take the ratio of sides, or 2/1. So now when we look at it, again, this is going from a smaller rectangle to a larger one. So we know that we're going to want that scale factor of 2/1. All right, let's take a look at C now. All right, so again, it's important that we match up those angles that we know. And we see here we have this angle here, right, and this angle here are congruent. Okay, so as we look at this, we want to see how could this thing go. So we're actually going to check 2 ratios. We don't know that this is similar right now. We just know we have one angle congruent. So let's go ahead and check a couple ratios. And let's start with the one we know is going to match up. The 4 is opposite that congruent angle, and then the 3 here is opposite that congruent angle. So if these are similar, then all of them will have that same ratio of 3:4. Okay, so I'm going to check the other sides, and let's see what we end up getting. Okay, so let's check first this 5 and see if that with the 7.5 gives us that same ratio. So that's 0.75, right? And now let's check 5 and its corresponding side 7.5. And when we divide those, do we get 0.75? And if you put in your calculator, you should see that you get 0.6 repeating. All right, so that tells us right away those aren't the same. Let's check the other one just for the heck of it. So the last sides that we have that match up are going to be here. This 4 right? And this 6 here. So 4 over 6, and that gives us 0.6 repeating again. So we have two of the corresponding pairs of corresponding sides have the same ratio. The third one doesn't, so these ones are not similar. All right, so let's flip it over to the back and see what we got here. All right, example 3. And the following, if the following polygons are similar, write a similarity statement and find the scale factor of figure 1 to figure 2. Okay, so right away we can see from figure 1 to figure 2 that it looks like it's getting smaller. So we know our scale factor has to be less than 1. Let's see if we can match up some corresponding sides, okay? So let's start with what we can match up, and let's match up the smallest side on each one, because if they are similar, the smallest will go with the smallest. So 7 will go with 5. So that's our first ratio. And let's check the rest, okay? So now let's go to the biggest, okay? And the biggest in this one is 25. And notice I'm circling this, now I'm boxing this one so I can see which ones match up really easily. It's 20 is the biggest, so if we check that, we're going to get 28 over 20. And if I simplify that, I can divide each one by 4, it looks like. Divide by 4, divide by 4. And there we get our 7/5 again, so we're close. Okay, we got two sets of corresponding sides. All right, let's go to the next biggest. Okay, so here the next biggest is going to be 21. Here the next biggest is going to be 15. So again, let's check that ratio, 21 over 15. Again, I can simplify this by dividing by, no, not 7. 7 doesn't go into 15. So how about 3? 21 divided by 3, 15 divided by 3, and that gives me that 7/5 again. Good. And then our last side we see here is the 14 and the 10. And again, 14 over 10. I can divide these by 2. And we see that we get 7/5. So we're checking all the pairs of corresponding sides. And again, notice how I did that. I started with the largest ones matching up, the smallest ones matching up, and then the next largest and the next largest. And we got the same thing. Now we got to try to match it up and make sure our similarity statement's correct. Okay, so when we look at this thing, let's match up the sides. So AB, look at the one that we circled. AB is the one I circled once, the smallest. It goes with FG. So we're going to start with FG. Okay. Next, look at our similarity statement. Now we have BC. BC is 14. That goes with GH. So there I have GH. And then the last one, CD. CD is the one with the triangle around it. Goes with EH. So that's HE. So there we go. They're similar. There's our similarity statement. Now our scale factor we got is 7/5. But now we want to think this was getting smaller. So we're going to take the reciprocal of that, and that's the one we want for our scale factor because it's getting smaller, so it's going to be less than 1 or 5/7 for our scale factor. All right, so example 4, find the indicated variables in the given similar polygons. Okay, so now we're going to match up. We're going to use our similarity statements. We're going to match up the corresponding parts. We're going to write a proportion. Okay, so look here, we have quadrilateral math similar to quadrilateral rock. Oh, that's hilarious. Math rocks. All right, now we have TH, and look here. TH goes with CK. Okay, TH I know is 15. CK I don't know. Okay, so that's not going to help me much. Okay, but what I do know is that this is a rectangle. So check it out. That's what I want. That's X. That means this side also has to be X. So that is going to help me. That's going to be my first proportion. So, or my first ratio for my proportion. So I'm going to set it up 15 over X. That's what I don't know. There's my two corresponding sides. Now I look at AT, right? And AT, we have right here. That corresponds with OC. Look at the order. So AT is 10. OC is 21. There's our proportion. All we have to do now is cross multiply and solve. Go ahead and take a second to do that. And we should get now that X equals 31.5. Now, every time you do these, you guys should be looking at the figures and thinking, does this answer make sense? Okay, so look, this one's 10 AT, and it's getting bigger, right? It's a little more than times 2. 10 times 2 is 20. A little more than times 2 gives me 21. 15 times 2 is 30. And 31.5 is a little more than 30. That makes sense. That's the whole idea of proportions. Think about it. Check your answer. Does it make sense when you get it? If it doesn't, it means you set up your proportion incorrectly. All right, let's look at our next one and see what we can figure out. Now, we have x and we have a y, so we know we're going to have to solve two different things here. All right, I'm going to set these up for you, then I want you to solve them. So let's look and see what we know and see if we can find two sides that correspond. Now, A, B, C, D, E. Watch, see we go around A, B, C, D, E. Corresponds with F, G, H, J, K. So look, the corresponding parts are lined up. That's awesome because it helps us really see which ones go together. So we can see AE corresponds to FK, and let's write a proportion there. So that gives us 6 over 10. That's the ratio we're going to use, or scale factor. Okay, and now if I want to find X, X is AB, put X up there, and X corresponds to 20. There's our first proportion. My second proportion, I'm going to start with that same exact ratio, 6 over 10. It works for any missing side in these figures because they're all going to be the same. Now look, I know CD is 9. That's going to go on the top because now I want to find side HJ, which is our Y value. Okay, so go ahead, take a second, solve those. Make sure you're showing your work on these notes so you get full credit for them when you turn them in. All right, and then pause it, and we'll check your answers. All right, so you should have gotten X equals 12 and Y equals 15. Again, check to make sure that makes sense. We know our scale factor is 6. It's going from 6 to 10. It's getting bigger, right? So this one now, if X is 12, that should be smaller than 20, and that looks good. Look, 10 is half of 20. That means 6 should be half of 12. It makes sense. Again, this is the idea of proportions. Apply that. All right. All right, next, let's look at example 5. What do we have here? Okay, so now we can see we're told that these are similar. Now look, we have some angles here to help us, and the angles are really just going to help us match up the corresponding parts. So if they're similar, we know the angles are congruent. So if this is 90, this is 49. 180 minus 49 minus 90 gives me 41. Similarly, gives me 49. Now when we match these up, we can see which angles go together and which sides go together. Okay. Now, I look at it and say this, okay, this side I know, across from the 49-degree angle is 12. Across from the 49-degree angle is 8. All right, so let's go ahead and set that up. Now, if you're keeping track, we have a whole bunch of blanks in here. We can start filling them in right away. There's an angle J we already found. Angle W we already found. Piece of cake. Subtracting from 180. Our angle statements, now this is really clear, right? We already have them marked in there, so let's just write the names. K, that's our right angle. T, our 41-degree angles are J, and R, and our 49-degree angles are M and W. Now what's nice is now to write a similarity statement, I can just go in the same order. So look right here. I have now triangle K, J, M, similar to triangle T, R, W. In that same order, because notice that the angles that are congruent are lined up in the similarity statement. Okay, now extended proportion of our sides, what does this look like? Okay, now we just take our similarity statement and we go in the order. So if I start with side KJ, I start with TR, the first two vertices of the triangle. Next I move to the middle, JM. RW. Notice the order that I'm going in. Then I did JM, so now I'm going MK, and then WT. There you go. Scale factor. Okay, now we want to find our scale factor, so we can use any sides that we know. We have to find two sides that we know that correspond, and we know that looks like KM corresponds to RT. KM. No, those are across from 41. No, see, this figure is kind of tricky, so we got to make sure we line them up right. So it looks like TR is going to go with, right, KJ. So that's 12, and TR is 8. So we're going to do 12 over 8, and that's the one we wrote over there. Now, the scale factor, if you can see, look at the sides, it's getting smaller, so we actually don't want 12 over 8. We want the reciprocal, or 8 over 12, and I'm going to simplify that. So divide each one of those by 4, and I get 2/3. Okay. Now we can find our missing sides. So we're going to start with that same ratio of 12 over 8. I started with triangle JKM, so I'm going to go to my other triangle. 12 corresponds to our side of 8. Now we look at 5. 5 is across from angle 41. Okay, that's TW, so 5 over TW. All right, there's our first proportion. The second one we're going to set up, we're going to use, again, that same ratio, 12 over 8 equals, and now what else do we need to know? We have the side 20, that hypotenuse, and that corresponds to our hypotenuse over here, which is WR or RW. Go ahead and take a second, solve those. Remember, we're cross multiplying here. And check your answers. You should get WT equals 3.3 repeating, and that WR equals 13.3 repeating. All right, one more to go here, guys. All right. Now it looks like we got a whole bunch of stuff going on here. Let's see if we can figure it out. If two polygons are similar, then the perimeters are proportional to the scale factor between them. So the same idea with sides applies to perimeters, okay? So all this mess up here is just adding up the sides. That's how you find the perimeter. So really, this is the perimeter of ABCD over the perimeter of PQRS. I don't know what happened to my B there. There we go. All right, that's what that's saying. That's the same proportion. All right, so when we look at this, okay, this next one, we want to do the same exact thing, okay? But look, we know some information here. Let's see what we can use. We know these are similar. Now notice this is A, B, C, D, E. It starts there. R, S, T, U, V starts there. And notice all the corresponding parts are lined up. Now here's what's cool. Look, I know these are congruent. That's 7. That's also 7. I know that's congruent to that. That's also 10.5. Nice. I don't know this bottom one. Let's see if we can figure that out in a second. But this is 4. I know that's going to be 4. Now these are going to be congruent, but I don't know what they are yet. Okay. But this guy, now we know the base ST. We don't know the base BC. So all you got to do is figure out one of these sides, and we're good, okay? So let's see, our first ratio then is going to be what I know. I know 7 and 4 correspond, so that's the ratio I'm going to use. I don't know BC, but I do know BC corresponds to ST, and ST is 6. So there's our first proportion, and that's really easy to solve there. Okay, so we have 7 over 4 equals BC over 6. Let's go ahead and cross multiply and solve, and we get BC equals 10.5. What do you notice about that? Look at that. 10.5, 10.5, 10.5. Now, if these are proportional, if those are all 3 congruent, that means these all 3 have to be congruent as well. So if that's 6, that's got to be 6, that's got to be 6. And there we go. We're done. That's what proportionality tells us. All right, so we can find each of these perimeters. Perimeter of A, B, C, D, E equals, add up all the sides. 7 plus 7 plus 10.5 plus 10.5 plus 10.5. Now, if you don't want to write all that, just write 7 times 2 and 10.5 times 3. Perimeter of R, S, T, U, V equals 4 plus 4 plus 6 plus 6 plus 6. And that gives me, add these things up, 45.5 and 26. And if we test that, those will end up being in that same ratio of side length 7 over 4. All right, and that's it for section 7.2. Enjoy your practice.